We talked about solving quadratic equations, what that looks like graphically. So if you graph the parabola that corresponds to the quadratic, then you want to find your x-intercepts there. Those are the roots and those are the solutions. That's what we did in 4.1. So 4.2, we're going to be dealing with the exact same stuff, except we're not going to be solving it by graphing. We're going to be solving it by factoring, so algebra methods. Okay, algebra methods. So you'll see in your textbook here, football, soccer, basketball, volleyball are just a few examples of sports that involve throwing, kicking, or striking a ball. Each time a ball or a projectile sails through the air, it follows a trajectory that can be modeled with a quadratic function. Each of these sports is also played on a rectangular playing area. The playing area for each sport can be modeled by a quadratic equation. So we're going to do this little first part here again, and I've done some of the work off to the side already, so you can kind of look at this and follow along. But when we're talking about volleyball courts here, okay, I don't know if you guys know this, but the length of the volleyball court is twice its width. So it's always 2 times as wide, as long as it is wide. So if x represents the width, then the length is 2x. The area, if the area of the court is 162 meters, then we can write a quadratic equation to represent the area. All right, so we can write a quadratic equation in standard form to represent the area of the court. So the area is right here. 2x, that's the length, right? The length times x is the width. So area is length times width. So if we write this equation in standard form, then when I expand this out, it's 2x squared minus 162 equals 0. Okay? So if we wanted to solve for x here, in 4.1 we would graph it and find the intercepts. Right? Pretty easy. So I think I've done that already for you here. Okay, so here's the corresponding equation to that, the corresponding function to this equation. See, it equals 0, so you just put a y there and you graph it, and this is what the parabola looks like right here. So 2x squared minus 162. So the roots or the solutions for x would be the intercepts here. So there's one, and here's the other. Okay, at negative 9, 0, and 9, 0. So x equals 9 or negative 9. Okay, that's the graphing way to solve this. So from your graph, what are the roots? Okay, how do you know that these are the roots of the equation? Okay, x-intercepts. In this context, are all roots acceptable? So would negative 9 and positive 9 both be an acceptable answer for the width of a volleyball court? No? Okay, why not? Thank you. You can't have a negative distance. That's right. So a negative distance doesn't, it's smaller than 0? No, it can't be smaller than 0, really, right? So it's just 9. Not a big deal, but it's 9. So 9 is the one solution that applies to the problem. Okay? Okay, step 2. Factor, and again, I've done this for you on the side already. Factor the left side of the equation. So here's the left side. If we factor it, you can remove a common factor of both of these terms of 2. And then you write 2 times what's left over, x squared minus 81. So this is factored right here. Okay? That's factored. And then we can go one more step by factoring a difference of squares, right? So this is x squared minus 81. That's a difference of squares. You've learned how to factor that before. So now we have 2 times x plus 9 times x minus 9. So this is sort of the introduction to how we do this algebraically. If we can factor the equation into its factors and notice that, hey, I have a binomial here, or I have my x's in these 2 factors, these are going to represent the roots. Okay? So watch this. There's something called the zero product principle. Zero product, and I don't think you guys have heard this before. Maybe you have, I'm not sure. But the zero product principle. Okay, so what is that? I'll type this out so it's a little bit easier. to read. Okay. In factored form, of a quadratic equation, the values of x that cause the factors to equal 0 are the solutions to the equation. And then that's because a 0 factor makes the whole expression equal 0. So that's sort of the principle, and I'll show you sort of how and why that works in a second here. Okay? And you'll hear me refer to the zero product principle quite a bit. All right, so just as we look at this one above here, this is a factor, this is a factor, and this is a factor. And factors mean that they're all multiplied together, right? So we don't have 5 plus x. Those are not factors, okay? This is not a factor, that's not a factor, okay? If they're multiplied, they're factors, all right? So if I wanted to find a solution to this equation, right, I would have to make one or all of these factors equal to 0 if I wanted the product to be 0. So what value for x will make 2 equal 0? Well, it doesn't matter what I make x equal, 2 will never equal 0, right? So we just kind of almost forget about the 2. Don't worry about the 2. It's still there, but we don't worry about it. Now this is where it gets interesting. What value for x here makes this equal to 0? And if you want to just solve for x, that's what you do. So x equals -9. Everybody see that? If x was -9, then this factor would be 0 and everything would be 0. That would satisfy the equation. And then also, what makes this factor equal 0? Well, if x was +9. Okay? So notice how the roots of this equation done algebraically match the x-intercepts on our graph. You see that? Everybody see that? Okay? So this can happen for anything. You need to be able to factor, though. Okay? You need to be able to factor. And that's what we're going to work on for the rest of the lesson here. Whoops, where are we? Okay. All right. So let's take this as an example here. Let's factor this right here. There's different ways of showing how to factor, but we just need to remember how to factor. Okay? So this is a quadratic, and let's say this equals 0, and I need to factor this. First thing you want to do is check for the greatest common factor and to pull out of all of the terms. So is there a number or a variable that is a factor of each individual term here? Yeah, you can take a 2 out of each. That's correct. So that's 2x squared minus x minus 6. So don't just eliminate the 2, you have to factor it, so leave it out front there. Okay. So now what we want to do is want to factor the inside. So in grade 10, we spent a lot of time learning how to do this. You may or may not remember. There's really two methods, just factoring by intuition. And again, you kind of do a quick FOIL method in your head, because a quadratic, a trinomial there can be a lot of them can be factored into 2 binomials. So these ones will be able to. Or the other method is decomposition. I'm not going to go through decomposition again. If you need to learn about decomposition, you can come and talk to me later, or you can look up the video on decomposition from Foundations of Math 10. Okay? But I will be doing most of this factoring by intuition, and I'll show you how to do that because it's the quickest, and once you can get some mental math going, it's easy. So let's factor this here. We know it's going to be 2 binomials if it's going to work. And the first two terms have to multiply to 2x squared. So let's make sure there's an x in each one. The only combination to multiply to 2x squared is 2x times x, because 2 is prime. Now, the 6, the last terms here, the last terms have to multiply to negative 6. You see that? So this is where some trial and error comes in and just some mental math comes in. You could try 3 and 2. Usually the factors that are closest together are usually the best bet. Now this is negative, so one has to be positive and one has to be negative. Now I just randomly put that in there, and you can do this too. Just make sure you have a pencil so you can erase, because it might not work the first time. And then what you do is you quickly do a FOIL method in your mind. So that's 2x squared, check. This is negative 4x plus 3x. Okay, what's negative 4x plus 3x? That equals negative x. Oh, look at, that's exactly what I have. So that's good. And then obviously 3 times negative 2 is negative 6. So we just randomly scored on the first shot here. Okay? So that's by intuition. Now if you choose the wrong factors, let's say I did this, right? If I did 2 here and a 3 here, then what I would get when I did a quick FOIL would be negative 6x plus 2x, and that's negative 4x. That is not what I have here. So this is not the correct combination. So just a kind of a quick FOIL mental math, you should be able to run into the factored version right away. But if you're unsure about factoring trinomials, you're going to need to do some background work on that. Okay? This is not the time for me to reteach that. So factoring. So what did we say it was there? Plus 3 minus 2, right? 4, 3. Okay. So now, zero product principle, you simply let 2x plus 3, that's one of our factors, let that equal 0, and let x minus 2 equal 0. Solve for x. It's really easy. And here x is going to be equal to negative 3 over 2. And here x is going to be equal to 2. So it looks like these should be our two solutions for x. If I were to graph this now, then I should get these as my x-intercepts. Okay? So I'm just going to try that here real quick, and let's just confirm. Okay, so over here is the corresponding quadratic, and I have negative 1.5. That is negative 3 over 2. And over here I should have 2. Okay? So we factor, let's finish the steps over here. Check for a greatest common factor and remove if possible. 2, factor. 3, let each factor equal 0 and solve for x. And then 4, verify, either by graphing or by just simply plugging your x values into the equation, right? Okay, any questions so far? So here's 3 examples for you. Just take a moment to try and factor each of these. Find out what the x values are, not by graphing, but by solving algebraically. Okay, let's go ahead and do that. I'll show you the answers in a minute. All right, so again, for number C here, the first terms have to multiply to this term. The last terms have to multiply to the constant. So you're basically just going to pick numbers out of a hat, right? So you're thinking 8 and 1, maybe 4 and 2, right? Which ones is the right combination to get you this middle term? So if you did 8 and 1, you could go, well, 3x and 8x. Does that combine to give me 2x at all? No. No. So it's not 8 and 1. Is it 4 and 2? Well, 4 times 2, let's make this negative and this positive. Does that work? Well, what's this? That's 6 minus 4. Ooh, close. That's positive 6 minus 4 is positive 2. So it's not negative 4 and 2. But could it be, could we just change the sign now? Could this be a negative 6 and a positive 4? Yeah. So again, just some trial and error, just some mental math, you can get that. And then here, 3x plus 4 now equals 0. We set it up just like this, and x minus 2 equals 0. And so 3x equals negative 4, x equals negative 4 over 3. And over here, x equals positive 2. So those are your two solutions. Okay. Look up decomposition method. That's the other method that I won't take the time today to show you, but decomposition method, you want to look up that one. Yeah, maybe if we have time here when you're doing your homework, I can show you. But I kind of want to get through this lesson here. Decomposition method is something you're going to want to look up. All right, let's work through some examples. This one just says factor, so let's just get a practice on factoring, guys. So 2x squared minus 2x minus 12. So I'm just going to write that over here so I can work with it. All right. So if we were to factor this, the first thing, remember the first step. So the steps I wrote up here, check for a greatest common factor first. So yes, there's a 2 that I can factor out of each term here. So you're going to do this. You're going to pull a 2 out, and what's left over is x squared minus x minus 6. Okay? Now we're going to focus on this trinomial, and again, that one should be factored into two binomials. So this is an easy one because a is 1 here, right, in this quadratic. So we just need two numbers that multiply to negative 6 and add to negative 1. So we'll put x here and x here. And then it looks like 3 and 2 are going to combine to give us a difference of 1, right? So we need to have a negative 1, so let's make it negative 3 and positive 2. And it doesn't matter which order you put those in. But negative 3x plus 2x is going to give you a negative 1x. And of course, if you just FOIL this out, you should get this back. So if you're doing this correctly, you should be able to multiply all that through and get this. Okay, so I think that looks correct. Does that look correct to you? Okay. So B is a little bit more challenging. Let's take a look at B here. So B is 1/4 x squared minus x minus 3. Okay. Well, what we could do is we could take out a greatest common factor here. Now we don't have to, but we could take out a common factor of 1/4. All right. So let's do that. Let's take out 1/4, and what are we left with? We're left with x squared. What's 1 divided by 1/4? See, that's a 1 right here. Yeah, 1 divided by 1/4 is 4. And what's 3 divided by 1/4? That's the same as 3 times 4 over 1, which is 12. So in this case, it's a good idea to take out this fraction as a common factor, even though it doesn't look like it was 1. Because this one is much easier to factor than this. So we have 1/4, and we're going to break that into two binomials. So we got an x there and an x there. So what are two numbers that multiply to negative 12 and add up to negative 4? Okay, so we've got 12 and 1, that's no good. 3 and 4, that doesn't add up to 4 at all. 6 and 2, okay, those are the two numbers right there. And we have to make it a negative 4, so guess what? We're going to make negative 6 plus 2. So boom, you put minus 6 in the first one, plus 2 for the other one, and then you should have that factored. There's no more common factors in either one of these, so you're done. All right. And finally, the last one is a difference of squares. So we have a perfect square and a perfect square. So let's factor that one real quick over here. So 9x squared minus 0.64 y squared. We're going to factor that into two binomials. We're going to take the square root of the first one, which is 3x. And that's going to be our first term. the square root of this term over here, so 0.64, well, 8 times 8 is 64, so it's going to be 0.8. And you can check this on your calculator if you want. Take the square root of that. And then because we have a y there, we have to make sure we have a y in each one of these terms as well. And then plus, minus. Difference of squares. Okay? You get that? Any questions? All right, so this is the last example I'll do for this section here. Factoring a quadratic form, okay? Now this looks a little bit complicated, doesn't it? Okay, but watch carefully. This is in the form of a quadratic expression. And what I mean by that is this. We have 2 times something squared minus 11 times something plus a constant. So that is in the form of 2, let's make another variable instead of x. 2 something squared minus 11 times that same something. Okay? So this is a quadratic. That's easy to see. All right? So when you come across something like this, if you see something that's in a quadratic form, but it's got another expression instead of just a single variable, this is what we're going to do. We're going to go let w, or some other variable, doesn't matter what it is, w, k, q, I don't really care, doesn't matter. Let w equal x plus 3. Then you're going to substitute that single variable in and make it easier to factor. So now I've got this one right here, and it's a trinomial, and I'm going to factor this into 2 binomials. This is going to be 2w times w. And I need to find 2 numbers that multiply to 15, positive 15, but add up to negative 11. So they're both going to be positive or they're both going to be negative. So what do you think? What are my options here? Do I have any options here? What are the factors of 15? 3 and 5, 15 and 1. Okay. Well, we have this 2 here, actually, don't we? So the factors of 15, don't go anywhere just yet, we're going to finish this up. The factors of 15, let's start with 3 and 5. The factors that are closer together are going to be the best. So because we have this 2 here, we're not looking for factors that have to add up to this because the 2 is there. So let's try 3 and 5. So what does that do? Let's make them both negative. That's going to be a 6, negative 6, and a negative 5. Does that give you negative 11? Yeah, it sure does. Okay? So, now, wait. One last step. One last step. Once we've got this factor, so this is good. Once we've got this factor, guys, we have to substitute x plus 3 back in. So watch this. This is 2 times x plus 3 minus 5 times x plus 3 minus 3. So this is 2x plus 6 minus 5. And this is just x. Simplified, this is what? What's 6 minus 5? That's 1. So 2x plus 1 times x. That is our simplified version. So substitute a variable in for an expression, factor it where it's easy, and then substitute it back in. Okay, so your homework is number 1 and number 2 for 4.2. Just a few questions for you to practice. So number 1 and number 2 for 4.2. Okay, so here's the key ideas for 4.2. Factoring a quadratic or a trinomial like this into 2 binomials is, we're going to be able to do that most of the time here. And when you let each factor equal 0, then the solution for x becomes your root. Okay, so the values that cause this equation to be true, basically. Here's an example where you have a quadratic form, so it's a little bit more complicated, but we're going to use substitution here, just as in the last example. And remember, difference of squares like this, p and q are different perfect squares, or even expressions. You can still factor it the same way, difference of squares. So there's question 1 and 2 for you to get your feet wet, and here are the other questions as well.